Hello everyone. In this session we are going to see the third example. Let's see. Write a ladder logic program to make on delay timer block works as off delay timer. So what they have given here is we need to use a one input and one output. That means whenever you are turning on, one output need to turn on. Fine. That is a normal concept. But what they have given here is we need to use a on delay timer block, but that should work as a off delay timer. What is the working of off delay timer? It will delay the off condition, correct? So whenever you are turning on an input, output immediately on. Whenever you are turning off the input, output takes some time. Maybe that according to the preset value we are giving, according to that it will be turning off. So this is the one we need to write. Got it? But to make this concept, we should not use the off delay timer. We should use the on delay timer block, but it should work as off delay. Correct? So don't confuse that how we can do it, because on delay timer if we are taking means that will work as a off delay or on delay only. That will perform like on delay, but with the logic, with some logic we can make use of the on delay timer to work as off delay timer. So with the logic everything is possible. Fine. So let's see how to do this in a software. Let's go to the software page. Fine. So now we are going to take a on delay timer only, but concept wise it should work as a off delay. So imagine if it is a off delay timer, whenever you are turning on an input, what should happen to the output? It should immediately on, correct? So let's do that first. I'm taking one input and one output in the same rung, because whenever you are turning on this, immediately your output need to turn on. So let's give some name. I'm giving input. This is the input and this is gonna be the output. O:0/0. Fine. This is what our output. First step is done. Fine. Whenever you are turning on, output is on. What is the next one? Whenever you are turning off, output should remains on. Can you get the point? Whenever you are turning on off the input, output should remains off. Okay, so for that what we need to do? We should latch it, correct? Because even though your input is going off, your output should go in a, remains in on condition, means it should be latched. Got it? So in this condition what should happen? In this condition, if it is a off delay timer, it will start counting. Whenever you are turning off, it should start counting, correct? Fine. So for that, I'm going to have a timer over here. In the same rung, I'm connecting a timer. I'm using the on delay timer block. See here, TON. Just give the timer address. I'm just giving the preset value of 10. Let's take 10. Okay. 5 means it will be a very little duration. So whenever you're turning off, this should started counting. Fine. So after counting, what should happen? It should turn off your output. So for that, I'm going to give the normally closed contact of our done bit here. So here you may have some doubt. This timer will start counting immediately whenever it turning on, no? Correct. So whenever you are turning on for the first time, this fellow should immediately on. So if you are not connecting anything to this timer, apart from input, if you are not connecting anything, it will be okay as a normally open, normally on delay timer, right? So it will be on. After 10 seconds, it will be automatically off. But my condition is not that. Whenever I am turning off the input, that time only this fellow should go counting, should start counting. So for that, I'm going to get help from one more input. I'm going to take one memory. Okay, what is that memory means? Whenever I'm turning on this memory is turning on B3:0/0. And what I'm going to do, and that memory I'm connecting here is normally closed contact with my timer. So why I'm connecting like this means this will restrict my timer to count in the initial condition. Okay, so let's see that. Because if I'm not putting this, no, it will be work as an on delay timer. So I'm restricting that from counting. Shall we see that? See, I'm turning on. Immediately my output is on. Can you see? Timer is not started counting. Okay. See, my output is on. Whenever I'm turning off, output is not off, but timer started counting. After 10 seconds, output should go off. What is this? This is exactly my off delay timer. Can you see output is off? I hope now you understand what is the use of this memory contact. Okay, because of this memory contact only, we are restricting the timer to count in the initial condition. See, whenever I am turning on this fellow is open because this is get energized. Because of this get open, the timer is restricted from counting. Okay, if I turn off, this will again comes to close, which will make a timer to count. Fine, because timer is getting complete input from here. Since it is latch, it is getting flow from here. So the run condition making the timer to count. Run condition making true. Run condition is true because of the output latch and this memory. So timer started counting. Simple now. So by using a logic, we made a on delay timer to work as a off delay timer. Fine. So just practice this in a software. You can use directly see, there is no place, no such application that we can utilize this concept. But with the logic, with logic we are making. So this is for your practicing purpose to play with the logic. Fine. Right. So just practice this in a software. I'll meet you in the next session with another interesting example. Thank you.